This physics-based computational engineering to aid product design or to aid engineering broadly. Was CFD among the early runners of that whole broader field, or were there other fields where physics-based numerical methods were already well adopted?
Yeah, great point. As it turns out, I think structural mechanics led the way. You might recall that Professor Zienkiewicz's very influential book came out, in the 60s even,
Yes.
right? And that and other advances sparked the entrance of finite element methods into structural mechanics and structural analysis. So, what I guess I was trying to communicate was in the field of finite element analysis, if you will, led the way. But the second area to mature, I would say, was computational fluid dynamics. Yeah.
But both were victories of mechanical engineering. So
Yes,
right?
absolutely.
So no other discipline outside mechanical had already bought into this power?
I would say, with the exception of, we think of aerospace engineering as a close sibling of mechanical engineering, right? So aerospace engineering certainly was no stranger to computational methods because in aerodynamics, mostly in the context of large airframe manufacturers like Boeing and similar companies, and in the military world, in the defense world, people had already started implementing software for computational fluid dynamics, but relatively simplified. They were not solving, for example, full Navier-Stokes equations with full viscosity effects or variable property effects. They were focused on Euler equations or inviscid type of calculations. So it had come along earlier than the general fluid dynamics sort of market grew, I would say, in science and engineering, but not broad, very special purpose.